Do you remember what effects does the A have on, would it have on any graph, but specifically to this trig graph? What does A affect?
Left or right, up or down.
What does it mean? Yeah, well, we've said the word stretching, but it has an effect on one specific feature of the graph. Do we remember? Or we can even move through our notes. Nice, yes. So this value here is going to be affecting the amplitude. So how would I find the amplitude? Do you remember how to find the amplitude?
It's like you from the bottom across, from the center to the
From the center line to the top, yes? Remember, there's a way that we can do it if it's not obvious where the center line is. Remember, we take our max, so the amplitude would be A, and so that's the maximum value. Subtract the minimum value and divide by 2. Yes, remember that now? So what is our maximum value? 27. And our minimum value was, and we divide that by 2 to get 6.5. Now, here's the tricky thing. They told us it's a sine graph. Yes, so in our minds we're thinking, right, what does a sine graph normally look like? Remember, it's like that? Yes? Does our graph do that? Does it go up, down, up? No, it goes down, up, down. Okay? So what do you think that means about this value here? It's negative. Nice. Are we all happy with that? Yes. So, since it is a reflection, oh my lord, in the, I'm going to say x-axis, but you know secretly I don't mean that, or upside down. The amplitude must be negative. So A is actually negative 6.5. Yeah, we're all happy with that? Mm-hmm. Alright, the next thing we have to do is find the other values. I'd say D is probably the next easiest to find. How would we find D? What effect does the D stuck on the end do to the graph? You can look back if you want.
It moves it to the right, to the left.
Okay, so the number stuck on the end. I'm really glad that our transformations and functions are embedded very clearly. So when you put a number stuck on the end, it shifts it up or down. Okay? Do we remember we've got x squared plus 4? It goes up through 4 and not goes through 0. Is that any recollection? Right, so our plus D shifts it up or down. Has this one shifted up or down? Up. Okay, so how do we find that central line? It's similar equation to this. So this D is where our central line is. Similar to this, what do you think we do? We do maximum plus minimum divided by 2 because we're trying to find halfway between them. Okay? So our maximum again was 27 plus 14 over 2 and then 41 over 2, so that's 20.5. So our value of D is 20.5. Alright, okay, so we've done A, we've done D. What does C do to the graph? Yeah, so I'm getting this side from green. Yes, so it's shifting it side to side. So we have to say again. That's right. Not quite, no. So because it's negative, it shifts to the right. This is a translation, not a stretch. Okay. So So it's shifting it to the right. So we want to pick a point that we're comfortable with, knowing that normally it goes through here 0, 0 at our central line. So where is our central line? 20.5, yes? Oh no, hang on a minute. I might have steered you in the wrong direction saying it's negative, because now I probably want to move this point to be over to here. What do we think? Because this point here is okay, you don't want to question. This point here would carry on going up here. Yes? So you could have different versions. So we could say that this point here has shifted this measurement away from here. Yes? Or we could say that this point here has shifted all of this movement to there.
Okay.
Yeah? Now, if we're going to choose this point having shifted, then it means that our graph secretly does go up, down, up. So therefore our value wouldn't be negative. Are you with me? Whereas if we did this bit, but we don't really know what this value is. Which is my quandary. What we could do is say, what would this point be? What would this point here be? Roughly. We have anything like that? 20.5? 5? Okay, so that'd be about 5. So what we could say is from the bottom of here to here was 3 units. Yeah? Are you following me? And so from the bottom of here to here would also be 3 units because we know it's symmetrical. So we know that could be negative 1. Yeah? So I looked at the bottom of my graph being here at 2. We decided this point here is about 5. And so this measurement here was 3, which means that this measurement here would also be 3 to the other side of the bump. So that would take it to negative 1. I don't know if this is a great option, but it's an option. Okay, so that means that our graph has actually shifted left. Yes? Are you with me? Shifted left. Therefore, it would be a +1. Yes? We like that? So what letter is it? C. So C is secretly +1. So it would be in our brackets T +1. So actually, if they've got that format, C is -1. Shut up. Because we want in our brackets T +1, but they've written T take away C, so then means C has to be -1. Now, so that's the option we're going with. If we had chosen the other way, then we would have had a value of probably 5, and we would have to take away 5. But then our value of A would be 6.5, not -6.5. So modelling is a little bit, well, it's not tricky, it's just appreciating that there are options, different options for you to do stuff, yes? Because the fact that they are translations of each other, it means that you can have different equations, but they all fit the same thing. Alright, so that's that. Now, what does D, what does that B? What effect does B have on the graph? Yeah, it does. It stretches it wider or thinner. And so what does it change? Or what feature of the graph does it change?
Period.
The period. Okay? So it affects the period of it. So remember, the easiest way of finding B is to establish how many cycles would it do? For this one, let's say what is the period of it. So normally the period would be 2 pi. and it's going to be divided by this value b. Okay, so our value of b is going to be 2 pi divided by whatever our period is. Alright, so we had this rule before, so the value of b is going to be 2 pi divided by the period. Now, why have I said pi and not 360? Look at these numbers. 2, 3, 5, 12. They're smaller numbers, yes? So application questions will always be in radians. Okay, so when we're talking about application questions, you're always going to be in terms of radians. So that's why we're always talking in terms of pi. And you wouldn't have 360 along here, so your period is not going to be that much different. Okay, so you're always going to be in terms of radians. So then we say to ourselves, okay, what is our period? Well, really, I'd say it was probably from 2 to 12, essentially. Would you agree? Because this one has started up and gone down. We don't know, this might continue going down. Would we say it was 12? I don't know. What do we think?
I did 2. Yeah.
2, 10 or 12?
12. Actually,
it is an estimate. I mean, we've got the whole year. The thing is, this might carry on going down, in which case it would take it up to 12, because this started here, and that finished at a similar temperature. Let's have a look. So it started at 15, finished at 16. And maybe we would say it was 12. Yes? Because that is our year, so maybe we're going to go with 12 here. So we would say it's 2 pi over 12, which is pi over 6. So now we've established all of those values, we would say that our function is t is approximately equal to negative 6.5 sine pi over 6 t plus 1 plus 20.5. Okay?